Hi, Dr. Fox here. Hope all is well. Dr. Pogrow has asked me to demonstrate two different things for you, power trio, and then also how to do correlation analysis in Excel. So the first thing we're looking at is the power trio. We know what that is. It's the mean or the average. And then we always put together with the mean standard deviation. So we always pair those two together. We're looking at them at the same time. And then the third one is the median. We use the median or the mean at different times based upon certain criteria. We're also going to be looking at a particular set of data, and we're going to create a table, and we're going to calculate the power trio. We'll plug that right into the table. We're going to be using the functions average, stdev, and median to calculate the power trio. And then we're going to look at correlation. So anytime you're looking at, is there a relationship between two different variables? So two different scores on something. As one goes up, does the other score go up of the other variable? As one goes up, does the other one go down? So we're looking at the direction of a potential relationship. If one goes up and the other one goes up, that is referred to as a positive relationship. If one goes up and the other one goes down, that's referred to as a negative relationship or negative potential relationship. If one goes down and the other one goes up, then that also is a negative relationship. And then if one goes down and the other one goes down, it sounds like a negative relationship if they both go down, but actually they're going in the same direction. That's why we call it looking at the direction of the relationship. So that one would be a positive. They're going in the same direction. So don't get tripped up on that. So one of the very first things that we do is when we do calculate or when we look at a correlation analysis is we do a scatter plot. So I'll demonstrate that for you. We're going to use the function of Correl, C-O-R-R-E-L. Some of you may use the Pearson function, so I wanted to just say that's okay to do as well. But they both calculate the same exact thing. There is absolutely no difference between the two. And then we're also going to look at the magnitude of that potential effect size. Magnitude of that relationship by looking at an effect size or interpreting an effect size. So I have some demo data here. Let me get me out of the way. And here's our power trio up here. We'll calculate using this small data set and then do correlation analysis looking at the relationship between engagement and a unit test. And we'll fill in these. We'll interpret the effect size. We'll also create a scatter plot. Then you can use this to replicate, but I've also we have the raw data from last time, so you can do it again if you want to after we get done. You can follow your instructor if he wants you to do that. You get the point. Okay, so let's go to the demo data, the demonstration data. To do the power trio, this should be a review. Sometimes we calculate them right at the bottom of our rows of data, but we can also create a table. And I've done that by doing, putting engagement and unit test on the rows and the columns mean, standard deviation, and median. So I click in the first cell. I want to do the average or the mean of engagement. I go right up to FX. It's already right here. If it's not in your block, just start typing average here and it will show up. So I'll click OK, and then I'm simply highlighting the data. Let go and click OK. There's the mean. I can do that for the unit test as well. Click on FX, click on average, click OK, highlight the data for the unit test, click OK. There's the average. How about standard deviation? Same thing. FX, STDEV, there it is right there. If it's not on yours, type it in. OK. The engagement, standard deviation, highlight the data and click OK. Click on the next cell. FX, you get the rhythmic here. STDEV, OK. Highlight the data and click OK. And then the median. FX. Here's the median here. If it's not in yours, type it in. It will show up. Click OK. highlight the data for the engagement, click OK, click on the last cell, FX, click on median, click OK, highlight the data, and then click OK. So we've done our power trio right in the table here. We can copy and paste this right into a Word document. When you do so, and you want to get rid of these lines down below, if you go up to the tabs on the top, click on View, and then you should see somewhere up here something called grid lines. If I uncheck that, you see all the grid lines go away, and then you can copy and paste and you won't have the lines showing, but I'll put them back on for right now. Okay, let's move on to correlation. I said the very first thing that we do is we run a scatter plot, but before we do so, we have to make sure we have our, and this is pretty obvious, but what is our research question? Is there a relationship between student engagement on some score and the unit test? So as student engagement goes up, does the unit test also? I would think so. I mean, that's my hunch. So let's do a scatter plot. Very first thing I need to do is highlight all of the data. I go up to the Insert tab, and then I look for a little icon right there, and it looks just like a scatter plot. If I click on it and then highlight the very first one and click, and there it is. That's the scatter plot. Now, a couple things I want to do. I want to add, so I'm going to click the little plus here. I want to add a trend line for a particular reason, and I also want to add chart titles. Oops, I'm sorry, axis titles. I already had a chart title. And what we have here on the x-axis is the student engagement. That was the first one, our first row. And typically we put the, like on the X, the independent variable. We think that student engagement is going to have an impact on a relationship with the unit test. And on the y-axis, we put, on the y-axis, we put the dependent variable. Though we're not doing causal analysis, we're simply looking at relationships. We're not proving anything. We're just saying, is there a relationship between student engagement and the unit test? Now, let me make this a little bit bigger. And one of the things that we want to do is I want to interpret like one of these little dots here. If I hover over it, it says series 1.30, 30,65. What that tells me is that there's a student who scored a 30 on student engagement and they scored a 65 on the unit test. 30 and 65. So if I go over to my data, I scroll, I look down here. Oh, here it is, 30 and 65. This little dot represents this case or this individual who scored a 30 and a 65. So that's where you get all the dots from. Now, one of the things that I said I wanted to add a trend line because we want to see, is this roughly linear data? So for example, and the answer is yes, it kind of forms a line. Those dots kind of form a line. But if our dots went up and then back down, that's something that we refer to as curvilinear, and there's a lot of different shapes. I'm not going to go into them all. But if it's not linear data, then we would not use correlation analysis. We would not use the test statistic that we refer to as R. It would be inappropriate. It would violate an assumption. So that's one of the things that we're looking at. The other thing that we're looking at is the line. Does the slope of this line go up from left to bottom left to top right? And the answer is yes. Guess what that means? That means we already know that the direction is positive. If this line went down, if it started up top left and went down bottom right, if its slope is going down, it would be a negative relationship, but this is not. This is a positive relationship. If these dots were all over this chart here and the line was pretty much straight, it would be like, oh, there's no relationship between the two. So that's what we're getting a picture of when we do a scatter plot. But let's go ahead and calculate the R test statistic by using the function Correl. Very quickly and easily, we click on the fx. We go down to Correl. If it's not in yours, type it here and it will show up. I click OK, and we have to put in two different data sets here, two different arrays as Excel calls them. So I click in the first array, I highlight the data. Then I click in array 2 and highlight the other data. And then I click OK. And our R test statistic is 0.850. It is a positive number. There's not a negative sign in front. If there was a negative sign in front, this direction would be negative and the slope would be going down. But so that's another way that you know if it's positive or negative. Is there a negative sign in front? And if there is no sign, then it means it's positive. Now, the last thing we have to do for correlation, we also have to interpret the magnitude, the strength of that relationship. How strong is that relationship? We do so by using, I use Cohen's table to interpret the effect size for correlation. Your instructor may use a different table, may use different words here, so follow whatever your instructor says. But there are a number of different ones that people use. I follow Cohen's. So I look at the R test statistic 0.850 and I go down the line here. Oh, here it is right here. It's greater than 0.8. So this tells me that it is a very strong effect size. So what do I know here? The R test statistic is 0.850. It's positive and it's a very strong effect, or a very strong relationship between student engagement and the unit test score. Okay, hopefully that's helpful to you, and bless. But hold on, time out. Everything that I just shared with you about effect sizes is the way I've been teaching it for years. That is, until I started reading Dr. Pogrow's Authentic Textbook series and found out he had a little bit different perspective, and I think a very good perspective on potential practical benefit of the bigness of a relationship. So we just said that we interpreted using this table here, which is Cohen's table, Cohens. Researchers have been using that for years. They're somewhat arbitrary numbers, and you get the concept of, okay, it's a very strong effect. But Dr. Pogrow says we really need to consider more or less practical benefit or potential practical benefit. So the way to do this would be to take a look at our R-square value. A lot of researchers use either R or R squared as their effect size for correlation analysis. So all you have to do is multiply the R by itself. So I'll do that with a very quick formula, equals this number, asterisk, which means times or multiplied, by this number, the same number, hit enter. And what we come up with is an R squared of 0.723. You can interpret it this way by transforming the ratio into a percentage by simply moving the decimal points over. And this is how coefficient of determination or magnitude is interpreted. We interpret it by saying 72.3 or 72% of the variance in the dependent variable or the unit test can be attributed to student engagement. Again, this is still relationship correlation type of analysis. So we're not saying that one thing causes another, but we can say, again, 72% of the variance in the unit test can be attributed to student engagement, the independent variable. So that's a great, when we think about this as 72%, wow, okay, that's obvious. That's a pretty big effect. But how far can you go down where you'd say, is it really an effect? I mean, is it 35% of the variance? That's still pretty good. Is it 20%? Is it 15%? I mean, once you get around 15% of the variance in the dependent variable, can be attributed by the independent variable, that's when you begin to think, well, how big of a relationship really is this? So Dr. Pogrow uses the criteria or the cutoff value of 0.39 of the R to determine really the bigness of a relationship in regards to potential practical benefit. So he uses 0.39 of an R, or the R squared of 15%. And technically it's 15.2, but so in a positive number, we're looking for anything for potential practical benefit greater than a 0.39 in the R value. So if it's 0.41, still it's greater than 15%, the R squared is. How about a negative number? Let's turn this to a negative 0.39. And guess what? It's still 15%. Because anytime you multiply a negative number by another negative number, it's a positive number. So when we think about the negative numbers, maybe it's 0.40. Okay, that's 16%. So it's negative 0.39, negative 0.40, negative 0.41, on and on. So we're really looking at the absolute value of 0.39 plus or minus for potential practical benefit. So this is how Pogrow what he actually says. In relationship research, to determine the bigness of a relationship, the criteria for potential practical benefit must be at least 0.39, positive or negative. Okay, now I can say it. Hopefully that's helpful to you, and blessings.